Welcome to E-Yantra Technologies. In this experiment, which is experiment number 6 of Jntuk R20 regulation ECE 32 Arduino and ARM based lab, experiment number 6, which is interfacing of DEAC, digital to analog converter, which is SPI based, serial peripheral interface based. So today we are going to learn how to do that. So in the manual provided to you, you will find a folder which is containing this experiment number 6 DAC, which contains the MCP 4811 underscore DAC as well as MCP underscore DAC master.zip. You will find these two files. Actually, this file is the library file for Arduino which you need to install. Without using this master library, you cannot run this sketch. So first of all, go to Arduino, open any sketch, there go to sketch, use include library, and then go to add zip library. We have downloaded this zip library, just click on it and give the path. It asks you for path where it is. Actually it is already added in my system, but I'll tell you how to do this. So here it's there on desktop, just a minute, desktop EYTM2. In this you have manual. In this manual you have experiment number 6 DAC. Select this zip, MCP underscore DAC master zip. Just click open. It might give you a warning that it's already existing. See, MCP library name already exists. I already had added this, that's why it is asking me. Otherwise, for you it will say that the library added successfully, right? So if you are using first time, you will get the correct one, but as I have already installed and I am once again trying to install it, it is throwing me this error. Okay, after successful installation, go to the folder containing MCP 4811 DAC, then click on it, open the sketch, Arduino sketch, and then in this sketch you will find, so here there is a DAC, digital to analog converter. Here this chip, it's a costly chip and it's not available in India. I have imported it from Hong Kong, so it's usually not available right now. So this DAC, it is working on SPI, serial peripheral interface protocol. So it requires actually 4 lines. The 4 lines are chip select, master in slave out, master out slave in, and serial clock. So 4 line bus is required for communication with the DAC. Those 4 wires are already connected to the Arduino's internal pins. Let me give you the description. So here the pin 2 is connected to the Arduino's 10th pin, which is slave select or chip select, and here the pin number 3 is connected to Arduino's 13th pin, D13. So D13 is directly connected to the pin number 3 here, and the fourth pin is connected to the pin number 11 on the Arduino. Actually, general SPI protocol requires 4 wires to be connected, but here in this only 3 are there. The reason is, this is the master Arduino and this is the slave, and the slave is not sending anything to the Arduino. That is, master is just sending commands, but master is not listening to this, because the DAC's purpose is only to read some number and accordingly set the output voltage. So it has nothing to send back to the Arduino. That's why the 12th pin on Arduino, the 12th pin, which is MISO, master and slave out, it is not used here. Otherwise, for general SPI protocol, you need to use that 4 pins also. These 4 pins you don't have to connect. Already they are soldered from the back side. Everything is available on the kit. It is wiring free kit. You can just plug and play. So just connect it here and upload the sketch here. Have a look at the sketch. In the sketch you have this include MCP, in this you have MCP DAC.h underscore DAC.h. This header file is not available in Arduino built-in. That's why we are adding a library. So that library gives you this sketch, and here this MCP4811 is the constructor which sets up the MCP class. So MCP series is microchip based digital to analog converters. Several numbers are there. It is 4811. It is a 10-bit DAC. It's a 10-bit DAC, which means you can set the voltage. Of course, here it is 5 volts. Everything is 5 on this board. So you can set the voltage of 5 up to 1024 steps. By sending a value 0, you can set the pin at 0 volt. By sending a value of 512, which is half of 1024, you can set at about 2.5 volts. And by sending full 1023, you can set actually up to 5 volts. But remember, these DAC chips, they do not give full voltage. Full swing voltage is not possible. At most you can get up to some, let us say if it is 5 volts, you may get around 4.5 or 4.2, something like that. More than 4 volts you will be getting, but full 5 volt swing is not possible with these chips. So you can take that particular voltage in steps of 1024. And this particular sketch is used for generating waveforms. You can actually generate the waveform like a triangle, square, ramp, etc. So here we are going to generate a waveform. Generally Arduino cannot produce analog outputs. We have seen the PWM. In PWM also it is still producing only 5 volts, 5 and 0. But the switching of 5 and 0 will appear as if it is giving an intermediate value. So strictly speaking, that is not analog output. So here we will be using the real analog output, which is continuously varying from 0 to the maximum 5 volts. So after declaring the object, we have the serial.begin. So once again we use the serial port, and MCP uses hardware SPI. So our microchip MCP, it is using hardware SPI. HW SPI means hardware. There are two possibilities. You can use software also, but here we are using hardware only. And for the user understanding sake, I have given the list here: D13 to chip select, D12 to MISO, D11 to MOSI, and D10 to serial clock. This is the pin description on Arduino and MCP 4811. So we start the microchip object here, and then set gain. See, we are setting 10 bit. And one more thing, here begin 10 we said, it means it's a 10 bit DAC. And set gain 2 means it can give up to 5 volts. Theoretically 5, but it doesn't come up to 5, it will come up to 4 point something. So if you put nothing and if you just put 1, or if you don't set the statement, then you will get only 50% of the voltage. That is, if at all you are feeding 5 volts, hardly you get 2.5 or 2.2 maximum voltage. You cannot get full swing. So set gain 2 gives you full gain. That's why we have to type the statement. And here this is the syntax: mcp.analog rate. Analog rate means it writes the value of the required one, and here value refers to how much, whether it is 10, whether it is 0 or 1023. 0 to 1023 you can set the value here. And channel, in this MCP series there are several channel DACs are also available, but this one is a single channel. Single channel means only one such a DAC will be there, and the channel number by default is 0. Channel number by default is 0. You don't have any option to set. So value only you can change, and the channel number is 0. It's fixed. So here we have generated a ramp wave. So this is ramp wave. Ramp wave means it's a rising sawtooth wave. So sawtooth wave means gradually it rises and then suddenly falls. Gradually it rises linearly and then suddenly falls. So we have used a for loop to set this 10 times. So we are going to generate the ramp for 10 times by varying the value. See, this is the core of this program. Just mcp.analog rate I, 0. 0 is the channel number and I is the value. When this for loop rotates, I value increases from 0 to 1024. So gradually voltage also keeps on rising. And in order to see this voltage, either you need a CRO. If you have CRO, you can see the voltage. And if you don't have CRO, then once again you can use the Arduino's analog pin only, which is the A7. So Arduino's analog A7 pin, which is connected to the DAC on our board. You can see here there is A7. A7 is directly connected to DAC. So if you remove the clip, you can use any other pin also, but here it is by default A7. So on the A7 we are going to read the value what is set by the DAC, and we are going to print it here. So this is the simplest program, and once again we will try to upload it. So when we upload the sketch, here there is a provision to see the visual waveform, not just numbers. We can see the numbers as analog read. Not only that, you can see the visual graph also, how the waveform is generated here. We are going to see it in a moment. Just it's getting uploaded now. It's uploading. Yes, now it's uploading and it is done. First you make sure that there are no COM ports open. See, none of the COM ports are open. So I'll go to the sketch, not sketch, it's the tools. Under the tools menu, you have a serial plotter and serial monitor. Serial monitor is the window which we have seen earlier, and serial plotter is a similar window which plots you the graphs. And please check the baud rate also here, it is 9600 only. Please observe, you can see a nice ramp wave. So ramps are generated like this, and it got stalled. Now you can see it's starting triangular wave. It gives for 10 times and then once again stops. Yeah, now once again ramp wave starts. You can see ramp and triangle. In that way you can also try with sine and other kind of waveforms, or you can even produce noise signals also with the same DAC. Thank you.